So now that we've covered the topic of asynchronous initialization, we also need to cover yet another concern, and that concern is asynchronous lazy initialization. So what is this all about? Well, imagine you have some class stuff. Now, you probably know that in ordinary.NET, what you can do is you can provide a value when it's actually required. So you can initialize a value with some result only when that is actually relevant and not when somebody just stores it somewhere. So here, for example, let me show you a very simple example. So I have some integer value, and let's suppose I want to have some order incrementing counter. So just as an illustration, obviously in the real world, you would just auto increment this and return this. But let's imagine you want to do it in a lazy way. So you'd have private read-only lazy int, and that requires the system lazy class, obviously, auto inc value. So this is going to be effectively a generator of order incrementing values, but it would be lazily initialized. So you would have a lazy int, and here the initialization would just do value plus plus, for example. So when you grab this value, it gets incremented by 1, and that's the value that you actually get. So here, if you want to use this value, you would simply go ahead and you would do the following. You would say int value equals auto inc value dot value. So this is okay because it's not asynchronous, because there is nothing inside the plus plus that requires an asynchronous call. But imagine a situation where you do require some sort of asynchronous call. Let's imagine that this lambda right here is a bit more complicated. So in addition to returning value plus plus, maybe you want to await something. You await task.delay 1000 and let's configure await false. Okay, so once again, this is something that is it's a viable solution, except that as soon as you have await, you have to do lots of changes, because obviously the lambda has to be async. So we make the lambda async, but then again, it's no longer a lazy of int. It's basically a lazy of task of int. So let's add that. So it becomes a lazy of task of int, and then I will also add it right here. But once these changes are done, then all you have to do is you have to await the value. So this way you can effectively wait for the value to become available based on some sort of invocation somewhere. That's how you would do this. Of course, you have to be inside an async method yourself, but this will actually work. This is okay. Now, I've chosen here to do configure await false, but in some situations, you might want to make sure that this operation, this lazy asynchronous initialization, actually happens on the thread pool thread. And in this case, you would slightly modify this entire approach. Let me actually just duplicate this code so that you can see it better. So order inc value 2 is going to do it on the thread pool thread, and the way this is done is that here the lambda itself is no longer async. It's just going to be an ordinary lambda, but here what we do is we do task.run, and inside task.run we have an asynchronous lambda. So I know it gets kind of complicated here, but basically, yeah, well, this is how you would launch the whole thing, and the end result is almost the same, except that we get rid of configure await false, obviously, but the end result is that this will now be always executed on the thread pool thread. Now you're probably thinking, well, if this is a common thing, isn't there some sort of wrapper? Can't we just build some sort of wrapper that simplifies this whole thing, some sort of async lazy wrapper? And in actual fact, you can find lots of different wrappers out there. The one that I'll show you is nito.asyncx, which does precisely this. So with this approach, you can write something, you can simplify effectively this whole thing. So you can have private static read-only async lazy of int, so it makes it a lot easier. Let's call it async or auto inc value 3, for example. And here what you would do is you would initialize it, so equals new lazy of task of int, and here you would specify an async lambda. So here you can pass in an async lambda, and inside this lambda you would do the same stuff as before. So basically it just saves you that little bit of time in terms of typing, because you don't have to do the whole task run business. It's kind of done behind the scenes for you, and except that I sort of slightly messed up here, because this has to be async lazy, sorry about that. So this does require a reference, but apart from that, like, this is really the only change that you would realistically have to do, and that's pretty much it. That will now function correctly. Of course, the actual argument is not task of int, it's just ordinary int here. So async lazy of int is a nice wrapper, which, as you can see, this chunk of code is a lot simpler than this chunk of code right here, but it does pretty much the same thing. So the takeaway from this demo is that when it comes to initialization, once again, you can do this in an asynchronous fashion. It does require you to write an asynchronous lambda as opposed to an ordinary lambda, but apart from that, it's fine, and you simply await the value which is generated by that async lambda. Absolutely no problem whatsoever. And you do have wrappers like async lazy, which makes the process of setting it all up and getting it working on the thread pool thread a little bit easier as well.